Hi pre-calculus students, this is the video for the retake of the Chapter 7 test. And for this particular test, because it was split into two parts, if you want to just retake the non-calculator portion or just retake the calculator portion, that is an option that's available. So reminder, if you didn't have all the homework in for Chapter 7 before we took the test, you're not eligible for a retake. You have to have it all in. Some of it can be for ones because it's late, but it does have to all be in. Now, first thing you're going to do, watch this video, take notes of everything, show all your work as you go through it, and make sure that you're catching those pieces that you're thinking, gosh, I might have been one of the people that made that mistake. Because I'm going to talk about the ones that I will frequently see people making mistakes on for this test. Number 2, go back in your notes and highlight the problems that are similar to the test problems. I have noticed recently that some of you are doing retakes even though you haven't even taken the notes over parts of the sections. And that's part of the reason that you're not doing well. So make sure that you are going back, completing those notes, highlighting anything, and all of that needs to be done before you take the test, and then you wouldn't have to go through a retake. Because our next unit, there's not going to be any retakes. We have seniors in our class, and the only fair thing to do is to not give retakes because the seniors would not have time to go through the retake process. So no more retakes for the rest of the year. So make sure you're getting caught up on all the notes before we take tests. Number 3, redo the review assignment. Take your time, make sure you understand the concept, show the details, especially on problems that you know that you struggled with. And then distance learners, you're going to make me a little video showing that you completed numbers 1 through 3 above without exception. In the video, flip through it, show me all the work. You can say, okay, this is the review assignment, and flip through that one. This is where I took the notes on the video, and flip through that one, etc. So I'll check to see that everything's been completed. Face-to-face students, please just show me all of your work before you take the test. And now May 25th would be the day before we would figure out, the deadline for the test. Again, these should be done in a Google Meet. So if you need to do the retake, distance learners, please contact me and we'll figure out before or after school time for you to do your retake in a Google Meet. And then number 5, the deadline for the retake is going to be May 26th. And notice I've got the start time here of 1:45. Please try to plan ahead. So, maybe make the 25th your day in your planner that you put down for the retake, getting all of that taken care of. We are under less than 20 days of school left, and wowzers, it is going super fast. All right, so this is the no calculator allowed portion of one of the distance learners tests. There were different versions this time as we have major concerns about cheating. Remember that cheating is aberrant behavior, and if you are signed up for the Pine Tech course and you are caught cheating, you will be expelled from Pine Tech, and that will be on your permanent college record. So make sure that you are doing your own work. Number 1, I would say there were some people that lost a few points because they had moved their x squared, or actually kept their x squared on the left-hand side, and then didn't factor out the -1 correctly. And so they had negative mistakes in here, but that was very rare. Overall, most people did perfectly fine with number 1 and substitution. Number 2, one person in both classes, maybe reverse that. It's always rows by columns. Then number 3, nobody messed up that one. You're just adding those, the entries, the numbers that are in the same entry, row 1, column 1, row 2, column 2, those types of things. Number 4, I don't remember anybody messing up that either, so you were careful with your subtraction. Number 5, however, this is, multiplication, it's a little harder to keep track of. So you have to think, I've got a 2 by 2 and a 2 by 3. The 2's in the middle do match, so that means I can do the math. And it needs to come out to be a 2 by 3. So now you think, well, here's the first position, and this is row 1, column 1. So that literally tells you what you have to do for your multiplication. You have to multiply the entries in row 1 times the entries in column 1 and find their sum. So negative 1 times 0 is 0. 3 times 1 is 3. 0 plus 3 is 3. And then we could do row 1 and column 2. Negative 1 times negative 2 is positive 2. 3 times negative 3 is negative 9. 2 and negative 9 add to negative 7. Row 1, column 3. Negative 1 times 7 is negative 7. 3 times 2 is 6. And negative 7 plus 6 is negative 1. And now you're done with row 1. So some people like to cross it off so you don't accidentally use it again. And now we go to row 2 and column 1. 3 times 0 is 0. 4 times 1 is 4. 0 plus 4 is 4. Now we have row 2, column 2, negative 6 and negative 12, total to negative 18. And then row 2, column 3, 21 and 8, total to 29. So it's getting used to the side-to-side and up and down movement that you have to have when you multiply matrices. Number 6, it seemed like there were people that forgot to even do the determinant before they started, and the determinant is AD minus BC, and we've got 0 minus a negative 3, which is 3, and then they did that, or they forgot that part of figuring out the inverse was multiplying by 1 over the determinant. So we need to do a scalar multiplication here of 1/3. But inside the matrix, for the main diagonal, we need to switch. So that's 3 and 0. And on the secondary diagonal, we need to negate. So if we negate negative 1, we'll get positive 1. If we negate 3, we'll get negative 3. So now you multiply by the scalar, and that gives you your inverse of a little 2x2 matrix. Number 7, row echelon form. There are a lot of different ways to do row echelon form. Some of you had a lot more matrices than this. You need to think, what's the easiest way to make this happen? And for this one, you could get away with 4 steps. And again, row echelon form is supposed to be top down. So it was again obvious to me who had not watched either the video or been at the Google Meet, because you were all over the place with your row echelon form. It really is easier, more basic to do top down. So we already have a 1 in this position, and that's great because we want 1s all on the main diagonal and 0s for these 3 numbers down here. So we need to keep that 1, 2, and 3 in the top row. But my first job would be eliminating this 4. So I realize I'm going to have to take negative 4 times this top row and add it to row 2. And that will, of course, replace row 2. So 1 times negative 4 plus 4 is 0, and we replace it. 2 times negative 4 is negative 8, plus 2 is negative 6. Replace it. 3 times negative 4 is negative 12. Negative 12 and negative 6 is negative 18. And now I've got that 0 in that first position, so my next thinking is, how do I get this to be a 1? And I look at negative 6 and negative 18, and I realize, gosh, if I just divided those by negative 6, this would be a 1 right here. And so we don't divide matrices, and we don't use scalars that have division. We use a scalar multiplication of the reciprocal, negative 1/6. So 0 times negative 1/6 is 0. Negative 6 times negative 1/6 is 1, and negative 18 times negative 1/6 is 3. So now we're good to go with row 1 and row 2. All right, down to row 3. Well, this 0 is good, but this negative 2 needs to be a 0. I don't want to go back up and use the top one because that will give me some numbers that will mess with my 0 if I change that one. So I'm looking at the second row, and I think, gosh, if I just take this times 2 and add it to this bottom row, then I'll have a 0 there. So that's what we need to do. 2 times 1 is 2, plus negative 2, and we get the 0. Because again, if you multiply 0 by 2, you're going to get 0, and 0 plus 0 is 0. So that ensures we're going to keep that original 0 that's in the bottom row right where it needs to be. All right, so back to this. Now we'll take 3 times 2, which is 6, plus negative 1 is 5. And I realize I'm super close. 0, 0, I need this to be a 1. Well, if I just multiply by a scalar of 1/5, it'll be a 1. And that was the fastest and easiest way to get that into row echelon form. Now, the things that would lose people points would be multiplying by something that was superfluous. It didn't need to happen. So make sure that when you are choosing something to do, if you realize later on, gosh, I didn't need to actually do that step, well, go back and fix it, rewrite it, erase the whole thing and start again. Go after things that are going to actually affect what you need to get to for row echelon. And just thinking back to other mistakes, number 7, there were some people that did reduced row echelon form. That's not what this said. This said find a row echelon form or a reduced row echelon as indicated for the given matrix. So that meant you had to read the instructions here for number 7, and it did say find a row echelon form. It looked like some of you read this top part, and for whatever reason you grabbed reduced row echelon form and you kept going with this. So you lost a point there. Then on number 8, you had to realize that this denominator piece right here is linear. Inside the parentheses, that's next to the first. So we could have had a denominator of x minus 7 in one of our fractions. We also had to have an x minus 7 squared because, again, we have to build these up in order to get our least common denominator here. And then this one, x squared plus 16, that's an irreducible quadratic. It's not factorable. There's nothing else we can do with it. So that means we need a linear term for the numerator of that one. So a, b, and cx plus d, and again you need the pluses. That's what partial fraction decomposition is. It's breaking this large fraction into pieces that we could get by using addition. Number 9 went very well. Occasionally, somebody did not get the x and y intercepts right for the line, for the linear inequality that was here. But everybody was able to graph y equals x squared. I mean, that was one of the examples that we had in class, was using y equals x squared. In fact, we had ones that were translated up and down. So this y equals x squared piece, the boundary for that curve, seemed to be a piece of cake for most people. If they made a mistake, it was just going too fast with linear inequality. And every once in a while, somebody shaded in the wrong spot. So you have to make sure, and over here in the green, let me move this over a little bit, make it a little smaller, you can see testing the points. And again, that's always a good idea, to test the points and figure out what's going on. All right, so that was the no calculator portion of the test. And this is the calculator portion. For number 1, people were able to go ahead and show me the matrices, what the result was. What people had trouble with was figuring out, what on earth am I finding? Well, you're taking the student times the tuition cost, so credits and cost. We've got 9 times 56 plus 8 times 87. So that's going to be their total cost of tuition from attending college A and college B. And then when you multiply row 2 times column 1, you end up with student 2's tuition costs. So it seemed to be, if somebody messed up, this was it here, explaining what on earth was going on, because it said find and interpret. So this is our interpretation. Number 2, pretty rare. Anybody messed up on this one? If you did, you probably just punched one in wrong. I mean, that's typically what happens with that one. Most people just use our REF very quickly and easily because it's something we know is going to give us the solutions for augmented matrices. Then number 3, this one, a little bit tougher for some, because you had to remember that if it's AX equals B, in order to use the inverse matrices, you have to take the inverse of A and then multiply it times B, but A inverse has to stay on the left-hand side, and that's because matrix multiplication is not commutative. So usually that one goes really well. Number 4, solve the system of equations. And in this one, we see we have 4 variables, and we only have 3 rows, which tells us we're not going to be able to get all of the solutions, but we will be able to write some formulas that would give those to us. So if we do our REF, you could use inverse matrices here too, but most people will use our REF. This says X, no Y's, no Z's, minus W equals negative 23. So that's over here. We have 0 X's, 1 Y, 0 Z, 4 W equals 7. And then the last one, no x, no y, z minus w equals 10. And we realize there's no row down here for w. Well, that means that's how we have to define all of this. So you'll notice w is the last number in our ordered quadruple here. And then we have to figure out, well, how can I write the others so that if they know what they're going to use for w, they could find them very quickly. So what we do is solve this little equation for x, this one for y, and this one for z. And you'll notice that w is what we have for the variable in all of those. And that's how we go ahead and write that. So again, punching it in wrong, getting a little lost because you couldn't find a w, that's usually what happens with that one. Number 5, this one usually goes really well because if you made a mistake on the non-calculator portion, usually you've looked it up before you've taken the calculator portion and realized, doggone it, I was supposed to have a linear factor up there. So a over x minus 3 plus bx plus c over x squared plus 3, and you realize that a is going to need the x squared plus 3, and that bx plus c from this part in the back here, the second fraction, is going to need the x minus 3. So we get ax squared plus 3a plus bx squared minus 3bx plus 3c plus cx minus 3c. And we know we've got a and b for x squareds with no c. And then the x terms are going to be the negative 3bx and the cx. And then the constants are the 3a minus 3c. So we go ahead and write those. And in this one, because there was no obvious, here's a, here's b, or here's c, most people are probably just going to use their calculator and do reduced row echelon form. And that, of course, will give you an a value of negative 7, which you need to put back here, a b of 4, and a c of 7. You put those back in these two positions, you show the addition, and you have it. Number 6, with this one, shading. If anybody gets anything wrong with this one, you usually have shaded in the wrong spot. So this one had an unbounded region, but they did just want the minimum value. So we had two that were really obvious. This was one that we had to graph, which was at 0, 10 up here. This was one we had to graph, which was 10, 0. And then we just need to find the intersections of our two linear inequalities, these top two right here. And you could either solve for y and put it in your graphing calculator, or you could use algebra, or if you graphed really carefully, I actually used a ruler to do these. I saw that it was 2, 4, and then I just went ahead and checked it and made sure that it was going to work. So now we take our vertices and we put those into the objective function, f equals 2x plus 4y, and we see the smallest number to get kicked out of this is 20. And that just said, find the minimum value. So saying that it's going to be 20 is good enough. Now, number 7, this one was the last of the non-extra credit, so the normal test problems here. And you just had to write an objective function and the constraints for the given problem. So looking back, this is where I said go after your totals. A summer camp wants to hire counselors and aides to fill its staffing needs at a minimum cost. The average monthly salary is $2,400 for counselors and for aides $1,100. The camp can accommodate up to 45 staff members. Well, there's a total right there. Less than or equal to 45. That's all they can hold. And at least 30 to run properly. Well, then we're saying we have to have greater than or equal to 30 in order for everything to go okay. They have to have at least 10 aides and may have up to 3 aides for every 2 counselors. So 2 pieces here, this didn't show up very well, but y is greater than or equal to 10. And I went ahead and made x the counselors and y the aides, so this says the aides have to be greater than or equal to 10. And then down here, we need 3 aides for every 2 counselors. And again, it said have up to 3 aides for every 2 counselors. So you have to realize that that's going to be less than or equal to for up to. All right. Then we have our 2 obligatory constraints. X is greater than or equal to 0 and y is greater than or equal to 0. And we could just go ahead and say, okay, I just need the objective function. Now, if you wanted to write these first 2 as one compound inequality, you could have done that, but most people tend to stick with the linear inequalities as they go through it. So the objective function was all about minimum cost, $2,400 for each of the counselors and $1,100 for each of the aides, and that is C. So again, you just had to write those. If you had time to do the extra credit, which is pretty rare because it takes a while to get all this graphed, there's a lot of big numbers here. Now you go back and you take all of your inequalities that you had for problem number 7 and you graph them. Boy, can I get all that in the screen up here? I think I'm going to have to make that a little smaller. There we go. You graph them, and this is, we made a change to the test afterwards to change the slope of the red line here, so I just whited it out rather than starting over. So we've got all of our lines in here. Here's our x plus y is greater than or equal to 30, but less than or equal to 45. So we know we're going to shade in between those two. And then we have to graph the 3y is less than or equal to 2x. Easiest to put that into slope-intercept form. So y is less than or equal to 2/3 x. Start at 0, and then use the slope to go up 2 and over 3. And then you go ahead and test a point to see where your shading needs to be, which the red you can see it's showing up not really well, but on this side below it was where we had to shade. And then that means this region right in here is the solution. So then we have to figure out where the vertices are. And the vertices here and here, actually not up here, right here and right here, because this was an unbounded region. We find these two by finding the intersections. So the green one down here was where we said y had to be greater than or equal to 10. So now here's the region, and you plug 1218 and 2010 in because that's where these two intersect. Again, if you graphed really super careful, you probably could have gotten them from your graph, but most of the time we're going to solve for y, find the intersection, either using the graphing calculator or algebra, however you want to do it. But that way we can figure out minimum cost of $48,600 with 12 counselors and 18 aides. And if you're able to get that one, that was worth 3 points. So that was, like I said, one of the versions that the distance learners had to take. And that completes the part where you have watched the video and taken notes on everything, particular attention being paid to things you know were not correct on your test. So go back and do the highlighting of the notes, matching problems that are similar to the test problem, redo that review assignment, and then whether or not you're a distance learner or face-to-face student, I have to see that work one way or another, and revisiting the deadline of May 26th. That's it for this video.